In this video, I will discuss the first law of thermodynamics. So this is very important. Many of you already know first law of thermodynamics. So in other words, you can say it is conservation of energy principle. So many of you already know when we did fluid mechanics, the conservation of mass principle, we already know. So what it actually means, the first law of thermodynamics or the conservation of energy principle. It means we have a very definite amount of energy in this world, and the first law of thermodynamics means we can't, we neither create or destroy any energy, but what we can do, we can only change the form of the energy. So energy from one form to another form. So it's clearly said, you say here, energy can be neither created nor destroyed during a process, but it can only change form. So from one form to another form, maybe the potential energy transform into the kinetic energy. So let's say here, we got an example, guys. If you look at this example, let's say this is a hill. We have a stone here on top of the hill. So we know the mass, and this is the elevation, or you can say the height, delta z. So if we go to this upward direction, that means the height, it will increase, the difference, it will increase. Anyways, so if we say that, okay, when this stone, it is at rest, it is on top of this hill, that means it is at rest, it's not moving, it's an stationary object. So which means if it is stationary objects, that means it has no velocity. So velocity is 0. And we all know the formula for the potential energy and the kinetic energy. So the kinetic energy, it is related to the velocity. So if the velocity is 0, then the kinetic energy here, it will be 0, because we now have v square, right? So v is 0, that means it will be 0. And the potential energy, it is related with the mass, the gravity, and the elevation. We know the formula, it is mg z. So here you can see delta z. So this is our potential energy here. So we know the mass, so we know the mass, we know the gravity is constant, and we have this, this elevation delta z. So the whole energy here, it is the potential energy when this object is at rest. Now, if we just move this stone from here, if this stone just fall down like here at this distance, let's say, so initially the stone was here, now it is here, and this distance is delta z. So look, guys, I told you earlier, if we go to the upward direction, that means this distance will increase. But if we just come to this downward direction, that means the distance will, now it will decrease. So initially, it was, if we go up, it will increase. If we go down, it will decrease. So in this problem, actually mass here, it is constant. Mass is not changing. Gravity is not changing, but the delta z, it will change. So let's say it was 10 initially, the height. Now let's say it is 5. That means the potential energy, it will decrease, isn't it? If it was this height, it was 10. Now where we say the stone is here, that means this height, it decreases. That means the potential energy will decrease. So now what we found, let's say we have the potential energy at this position, it is 7 kilojoule. Which means we had the total energy 10 kilojoule, now it is 7 kilojoule. So, and the remaining 3 kilojoule, it will be the kinetic energy, because now it got some velocity. When it moves from here, this top of the hill to this, this bottom, then it will get, so velocity is not anymore 0 when it is moving. So that means now we got some kinetic energy at this position. So the sum of this total energy is 7 plus 3, that means 10. So it is equal. So you can see initially we had no kinetic energy, and now it becomes some potential and kinetic energy, and in sum of these two energy, it is equal to the initial energy. So in mathematically, if we consider this first law of thermodynamics, we can get two different thing. So two different kinds of mathematical expression we can expect from the first law of thermodynamics. So during the process, one is during the process, one is during the cycle. So when it is process, let's say you supplied some energy Q. So if you supply energy, that means this energy will transform into work. Q is the energy, W is the work. And we said earlier, heat is low efficient, so heat can't transfer or convert 100% energy into work. So what we'll do, we'll get some energy inside the system. We said this is actually the internal energy. So it is the heat, W is the work, and this is the internal energy. So this is actually the form of the first law of thermodynamics when you will consider the process. But if you have a cycle, so that means the cycle means we can write it this way, delta Q. That means the net heat interaction during the cycle, delta Q, it will be equal to the net the work interaction during the cycle. So this is delta W. So this is when it is a cyclic system, then we will get the first law of thermodynamics is like this. The mathematical expression, it will be like this. So we can just discuss this on here in the next slide. You can see here, guys, we said the first law of thermodynamics states that the cyclic integration of the heat transfer is proportional to the cyclic integral of the work transfer. So when it is a cycle, the integral interaction of the heat transfer, it will be equal to the work transfer. This is actually for SI unit J, it is equal on. So forget about it. Here actually it will be the cyclic integration of delta Q. It is equal the cyclic integral of delta W. That means the heat interaction, it will be equal to the work interaction. So that's actually the summary of the first law of thermodynamics. We can't create or destroy any energy, but we can change the form. So I think that's it.